So let's talk about a little bit more about the motion in one dimension. So a recap of what is velocity. Velocity is a rate of change of displacement. For us, being a calculus class, the velocity is going to be defined as dr over dt, which is the rate of change of displacement. Since r is a vector, it is a displacement, it is going to have components. It's going to have an x and y component followed by the unit vectors I and j. Acceleration is defined as the rate of change of velocity. The average acceleration is defined as dv over dt with units of meters per second squared. Instantaneous acceleration is also a vector quantity, so when you're talking about acceleration, you have to know that it's going to be dv over dt, and v is a velocity vector, so it's going to have two components, vx and vy. So now let's do an example. A particle moves in the xy plane such that its x and y coordinates vary with time according to these equations given. X equals at cubed plus bt and y equals ct squared plus d. Note, both x and y are a function of time, where the values of a, b, c, and d are given. Our job is to find the position, the velocity, and acceleration of the particle when t equals 3 seconds. So in order to solve this problem, first of all, we are going to write what is given. So we are given x as a function of t, which equals at cubed plus bt, and it gives me y as a function of t to be equals to ct squared plus d. Okay, and it's asking me that I have to find, given these two, position, velocity, and acceleration at t equals 3. So my first job is that I need to find my position vector. So the same thing as we did before, my position vector is going to be xi plus yj. Okay? What I need to now do is, since I have the equations for x and y, I need to be able to put these in here. So it's going to be at cubed plus bt I plus ct squared plus dj. That is going to be my r as a function of time. Now the question says I have to find this position at t equals 3 seconds, which means I have to plug in the values of t here, here, and, oops, sorry, nothing there, as 3 seconds, which means it's going to be a 3 cubed plus b 3I plus c 3 squared plus d j. Okay? It also gives me the values of a, b, c, and d, which I can plug into here, 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 and here. Oops, sorry, wrong place. Here. Okay? Which means that r now at 3 seconds is going to be blank I plus blank j. And I'm going to leave these blanks up to you guys to fill in. Okay? So now this is going to be my equation for r. Now comes my next problem. Now I have to find velocity. Velocity as a function of time. So what do I know? I know velocity is written as dr over dt, which basically means is, since r is x and j, that means this r should be x and j and the derivative of x and j. So let's make it simple. So let me do it this way. So I'm going to have a dx over dt, and I'm going to have a dy over dt. So pause the video here and try to go solve it yourself. And I'll tell you what I get. So if I have this as t, I will get 3at squared plus b, and I will get a 2ct plus 0, right? So I took the derivative of x and y, and this is my answer. So my v velocity is now going to be rewritten as dx over dti plus dy over dtj. Okay? Then I can plug these values from here in here and in here. So my velocity is going to be 3a. Note, this velocity is as a function of time. 3at squared plus b I plus 2ctj. Okay? Similarly, since the question asks me to find it at t equals 3 seconds, all now I have to do is put in 3 seconds for my time and be able to solve it. So I will have a velocity at 3 seconds be some number that I get from here multiplied with an I, which is the unit vector, and then I will have a j unit vector multiplied by a number here. Now my last problem is to find acceleration. What do I know about acceleration? So I'm just going to use a little bit of space that's left over here to solve that. So my acceleration, remember, was so I'm just going to use here. So my acceleration was dv over dt, if you remember correctly, right? This is now going to become dvx over dt plus dvy over dt. Okay? This is going to be my vx, and this is going to be my vy component. So then I will have to plug in this value in here and this value in here and be able to solve it, which I can easily do, knowing that this is going to be 3at squared. I can take the derivative of it, which will be 6at plus 2c, right? Notice I made a mistake. I didn't put an I and a j in here. So this will be this and that. And what I'm going to be left with is going to be a as a function of t will be given by that expression right here. Right? And that brings me to a general answer for this question. So I have an r as a function of time, I have a v as a function of time, and I have an acceleration as a function of time. So let's say the question asks me to find it at t equal 10 seconds. All I have to do is figure out what these equations are right here, and right here, and right here, and be able to solve them, take the derivative of them.